In this presentation, I will explain recurrent neural networks. Here, I will give introduction about the recurrent neural network. First, introduce to RNN. Recurrent neural networks are a type of neural network where connects between nodes can create cycles allowing the network to maintain a state that can capture a temporal dynamics. Here have a key features for the RNN. Here used to ability to process sequence of data such as time series, test, or any data that comes in sequence. For here very used to time series, test, and any data. Then I will tell architecture of RNN. Standard RNN architecture show a simple diagram with input, hidden state, and output layers, highlighting how the hidden state is updated with each time step. Then I will tell types of RNN. Vanilla RNNs, long short-term memory, that is LSTM, gated recurrent unit, GRU. Vanilla RNNs means basic form with one hidden state. This is used for one hidden state. Then long short-term memory, that is LSTM. Introduce LSTM cells that help in learning long-term dependencies by using gates, input, output, and forget gates. Here are three types of gates. Then other type of the RNN is gated recurrent unit, similar to LSTM but with fewer gates. Reset and update gates. Here have two more reset and update gates make it to RNN. Those are the short introduction about the RNN. Sample for recurrent neural networks. Here I am going to explain step by step for time series prediction using recurrent neural network. This code used to weather data to predict temperature. Then first we have to import necessary libraries such as pandas, numpy, matplotlib, sklearn, TensorFlow, sequential. Here use pandas for data manipulation and analysis. Here use numpy for numerical operations. Then use matplotlib pyplot for plotting graphs. Then use sklearn model selection train test split for splitting data into training and testing set. Then use sklearn preprocessing min-max scalar for normalizing the data. Then use TensorFlow for building and training the neural network. Then use sequential LSTM dense for creating and defining the neural network model. Then load the dataset. Load the weather dataset from the specified path. Then we select the relevant columns. Select only the formatted data and temperature column from the dataset. Then we convert formatted data to datetime and set as index. Convert the formatted data column to datetime format. Then set formatted data as the index of the data frame. Then we will move to the normalized data. Normalize the temperature data to a range 0 to 1 using min-max scalar. Then we will move to the split data into training and testing. Split the normalized data into training 18% and testing 20% sets. Then create sequences. Define the functions to create sequence of a specific length from the data. Create sequences for both training and testing set with a sequence length of 10. Then we are going to build the RNN model. Here create the sequential model at the LSTM layer with 15 units and ReLU activations. Here use ReLU activation function at the dense layer with 1 unit. For output, compile the model with Adam optimizer and minus got error loss. Then we are going to train the model. Here, train the model for 10 apertures with the batch size of 1. Use the test set for validation during training. Then we are going to make predictions. Make predictions using the training model on the test set. In Buzz, transform the scale prediction and true values back to the origin scale. Then we plot the result using plot the actual and predicted temperature values. Add labels, title and legend to the plot. This code aims to predict the temperature value based on the past temperature data using an RNN model. Here we can see the temperature prediction using RNN visualization according to the actual and predicted.